important topic. So, in motion in a straight line, we will discuss about motion, rest, reference frame, distance, displacement, speed, velocity, and that's enough. And acceleration also will discuss. And equation of motions are there. So I will give the formula. So these topics I will discuss now. Coming to the motion, with respect to time, the object moves. So I'm considering the book is here. So I'm taking this a book. So this book is at no with respect to time, the book is at same place. We cannot say the body is in motion. We cannot say the body is in motion. So with respect to time, the body is moving from one point to another point. Then we can say object is in motion, right? So with respect to time, the object moves. Then we can say object is in motion. With respect to time, the object does not move. Then we can say object is at rest. And coming to the reference frame, so with this help we can observe all the motions. Like I'm standing at the railway station, so I'm the reference frame with respect to me. So train is moving, so running train is there, the train is moving. So with respect to me, the fan is rotating, like that we can say. Okay, so these all observations we can make. That is about reference frame. And next one, coming to the distance. Distance is nothing but the length of the path covered by an object. The length of the path covered by an object. So from here to here, I want to travel in this distance, in this way, like this. So everywhere we can consider, right? So the length of the path covered by an object is called distance. And the displacement is nothing but the total distance traveled by an object. The total distance traveled by an object is called displacement. The total distance traveled by an object is called a displacement. So I hope it is very clear to you. And next one we can go with the another point. So which one will go? Speed. Speed is nothing but the total distance traveled by an object per unit time. The total distance traveled by an object per unit time. Simply we can say distance traveled by an object per unit time also we can say. So that is about speed. Speed is a scalar quantity. Speed is a scalar quantity. SI unit of speed is meter per second. And the dimension formula is, what is the dimension formula? Dimension formula is m power 0 L power 1 T power minus 1. M power 0 L power 1 T power minus 1. That is the dimension formula. And coming to the velocity, velocity is nothing but displacement per time, or the displacement traveled by an object per unit time. Displacement traveled by an object per unit time, that is called velocity. Velocity is a vector quantity. So why velocity is a vector quantity? Velocity has both magnitude and direction. Velocity has both magnitude and direction. So it is a displacement. We are talking about the displacement. What is the displacement? See, from one point to another point, I can go in many ways. Like this, I can go in this way, I can go in this way, I can go. Many ways I can go. But the shortest point, from here to here, the shortest path, okay, so initial to final, the shortest path is called displacement. So it has particular direction and at the same time magnitude also there. That's why displacement per unit time, we can say velocity. Velocity is a vector quantity and SI unit of velocity is meter per second. And dimension formula is m power 0 L power 1 T power minus 2. That is about T power minus 1. M power 0 L power 1 T power minus 1. That is about dimension formula of velocity. Understood? Yes. So that is about differences. And coming to the acceleration. Acceleration is nothing but so those who are watching, please do like, at least if you like the video, so that will reach to the other another students. Hi Arjun. Hi. So that will reach to the remaining students also. They will also join to the class. Okay, done. So coming to the next one, acceleration. Acceleration is nothing but uh, change in velocity by time taken. Change in velocity by time taken. Final velocity minus initial velocity by time taken. That is called acceleration. Acceleration is a vector quantity. So because velocity is a vector quantity, change in velocity, acceleration, and so both are high adrenaline. So that is about okay. So I hope it is clear to you. That's about acceleration. And coming to the next one, equation of motions. So equation of motions means, so v equal to u plus at, s equal to ut plus half at square, v square minus c square equal to 2as. So these are the equation of motions. So there are two methods. There are two methods to solve this. To solve to prove that and to derive this equation, there are two methods. One is integration method, one is graphical method. So with those two methods we can identify, we can find out the equation of motions. And now we can go with the that's enough. So based on the, see in these cases, there are two applications we can go with that. So what are those applications? Especially problems. So when you are throwing the object upward direction, here acceleration due to gravity is minus, and final velocity is 0. Why acceleration due to gravity is negative? Because object is moving upward direction. Object is moving upward direction. So it is moving against the acceleration due to gravity. That's why. So g value we will take negative. G value we will take negative. And coming to the body, free falling body, if the body is dropping down, that time what will happens? That time also we can take initial velocity 0, and acceleration is positive because object is moving towards the ground. Okay, every object will attract towards its center. That is called acceleration due to gravity. Okay, so object must be, see, if you are throwing the object, so it goes up, right? Again it comes down. How much force you are applying, until that much force it will reach, again it comes to ground, right? So that is about equation of motion. uh, that's, I hope that is about. And here we will also mention the inertia of rest, inertia of motion, inertia of direction. So those are very very important, that we will discuss in laws of motion. So in today class we are working with only, what is that, motion in a straight line. So we discussed only today motion in a straight line. So we'll see in the next class, we'll in the next live classes we'll go with the remaining topics also. So until that time, so keep follow and keep subscribe. Thank you so much.